Welcome to another video of Naukri Learning. So in this tutorial, we are going to look at how to get all the prime numbers in a given range using Python. And we will use multiple approaches and see which one works the best. So before starting, let us get a quick brush up on what prime numbers are. So any number which is not divisible by any other number apart from itself and 1 is called a prime number. Okay, if it is divisible by any other number apart from itself and 1, then it's a composite number. 0 and 1 are not prime numbers. The first prime number is 2. Okay, so let us check an example of say number is equal to 9 and see whether it is a prime number or not. So in order to check whether 9 is a prime number or not, we will start iterating from 2 till it reaches n minus 1, which is 8, and see if 9 is divisible by any of these numbers. We will check if 9 is divisible by 2. That is not true, so we will skip to the next one. That is 3. And we see that 9 is divisible by 3. So 9 is divisible by some other number apart from itself and 1, which is 3. And thus 9 is a composite number. Okay. Let us see another example of where n is equal to 11 and start iterating from 2 till 10. Okay, so 11 is not divisible by 2. It is not divisible by 3, 4, 5, and so on till 10. Thus, 11 is a prime number. Okay, so let us just implement this particular logic directly in Python and see how the code performs. So let us implement the process that we discussed right now and see how that performs. Okay, so for this, I will just create a function for this approach one. It will take an input n, the number that we want to check if it is a prime or not. And first, we will check if this number is 1 or 0. If it is 1 or 0, then it's clearly not a prime number. Else, we will proceed and loop it through till 2 till n minus 1 and see if any number is able to divide it or not. So mind you, in range iterator, we get the higher bound as n minus 1. The number that you give as a higher bound, it's taken as one less than that particular number. Okay, so if you are providing range till 2 till 9, then it will iterate from 2 till 8. Okay, and we will check for the same because we need till that only. Okay, so we will check if n modulus I is double is equal to 0. So if it is perfectly able to divide it or not. If it is true, then we will return false, else we will return true if it falls under neither of these conditions. Okay, and then we will just create the driver code for this. Also, we will check the time for this, the time taken for this particular performance. This per forgotten gives us in seconds the amount of time that is taken. Okay, so we will say and for the given range when n is equal to say 10,000, we want to see how many prime numbers are there. Let us print a dictionary about this. Also, let us make this 10,000 in order to understand the performance of the code. Okay, so we'll quickly run this and see the result. Okay, so within 1 to 10,000, there should be 1, 2 to 9 prime numbers, which we are getting as a result over here as well. And the total time taken for this is about 0.39 seconds. We have seen one naive approach about solving this problem. So let us understand how we can optimize this with some different approaches. Okay. So if you look at any particular number, say 9 or 10, 11, you will be able to see that none of the numbers will be divisible by any number which is greater than half of it. Okay. So if you take 10, then none of the numbers 6, 7, 8, or 9 will be able to divide 10. Okay. So is the case for 9, and so is the case for 11. So do we actually really need to iterate till 8 in order to check whether 9 is prime? No, right? So all we can do is we can iterate till 9 divided by 2, and we can round this up in Excel just to see how this works. Okay. All we need to do is check till 6. That is enough. Okay. Let's try to implement this particular logic in this code itself and see how this optimization performs. Okay. So I will just copy paste this entire thing, and I will write it approach 2, and instead of iterating till n itself, which is n minus 1, we will just iterate till n divided by 2, which will give me the absolute division value, or the floor value, okay, plus 1, bracket close, and this is it. And instead of using prime number approach 1, I'm going to use the check if prime approach 2. We'll just duplicate this line, replace the function, and comment this line out and see how this performs. Okay, see, we got an improvement in our timestamp. From 0.39 seconds, we are able to reduce that to 0.24 seconds. So for this, I will just write this particular timestamp and save it over here. So now that we have seen one naive approach and one optimized approach based on some mathematical rule, let us see one other approach which is also based on mathematical rules in order to find a prime number. Okay, so if a given number n is not divisible by any number which is less than or equal to its square root, then it is not going to be a prime number. Okay, so just for this example, the square root of 9 would be 3, and since it is divisible by 3, we need not go any ahead and check whether any other number will be able to divide it or not. So none of the number which is greater than uh, the square root of this number would be able to divide this number if any of the number lesser than or equal to the square root of this number is not able to divide it. Okay, just for a practical example, let us see the square root of 11. So we will just write square root 11 and see it is 3.31, and we will just round this up and add a 1 up at the end. So all we need to do is check from 2 till 4 and see if any number is able to divide 11 or not. This will also reduce the entire time that we had spent earlier. Previously, we were checking it till the half of it, which would be 6. And right now, we will be just checking for 3 numbers instead of 5 numbers. Okay, so this will all in turn reduce the number of times the loop has to run. Okay, so we'll just quickly jump to PyCharm and get this implemented. So I'm going to copy this approach again, paste it over here, write it approach 3, and for this I'm just going to import square root function. So from math import square root, and I will put in square root of this. Again, we'll just duplicate this line, change this function name, and run this file. Okay, so you can see that it has again drastically reduced to half of the time that it was previously taking. So we'll just copy and paste it over here as well for reference. So let us quickly jump to the Google Sheet and understand how this algorithm works. Okay. So for this, let us take an example of n is equal to 30 and let us get all the prime numbers within this range. Okay. So the first thing that we need to do is we need to mark all of these numbers starting from 1 till 30 or say 2 till 30 as prime numbers. And then we are going to slowly iterate over these numbers and mark them as not prime. Okay. So the first thing is starting from 2, unmark all the numbers which are multiple of 2 and are greater than equal to the square root of 2. Okay. So starting from 2, we will see which particular number is the square of 2, which is 4, and all the multiples from there onwards till 30, mark them all as not prime. Okay. So that will include 4, 6, 8, 10, 12 till 30, and we will mark all of them as not prime numbers or composite numbers. So the next step includes from all the numbers that we are left with, see which particular number after 2 is still marked as prime, okay, which is going to be 3. Okay. Then again repeat the same step with 3, find the number which is the square of 3, and from there onwards for each multiple of 3, eliminate them as prime numbers. Okay. That will include 9, 15, and 27 in this particular iteration. Great. And now repeat this above process till you get to a marked number whose square is greater than the number that is the range number that you're trying to look at. Okay. In our case, it's going to be 30. So the next thing we need to do is figure out which particular number after this previous step is still marked as prime number. So that is going to be 5. Do we have the square of 5 within this range of 30? We have. That is 25, right? And we are going to mark that as a non-prime number. And the next number after this is 30, and we already have 30 as marked as composite number. So the next iteration is going to be, we are going to check which particular number is still marked as prime in this particular list after 5. That is going to be 7. Is the square of 7 within the range of 30? No, right? So we are going to break it. We are going to break the loop over here. So all the numbers starting from 2 till 29, which are still marked as prime, are the prime numbers within this range. Okay, that is going to be 2, 3, 7, 11, 13, 17, 21, 23, 19, and 29. Okay, great. So now let us jump back to PyCharm and see how to implement this in Python. So let us write the code for this particular approach. Just give this particular name and take n as input. Okay. So first we need to define the list for all the numbers and flag them as prime. Then we'll set our counter from 2 since that is the first prime number, and we will set our loop so that it is always less than equal to the power of p to the power 2 is always less than equal to n. Then we will check if it is already a marked number or not. So we will check whether it is technically marked as prime still. If it is yes, then we will proceed. Otherwise, we will continue towards the next unmarked number which is still prime. Okay, and we'll increment p by 1 every time we do this. Finally, we are going to write this to a dictionary with the same format. Okay, and I'm just going to change the driver code a little bit for this and write it this way to get the output or in the similar format that we were getting previously. Okay, so we'll quickly run this and check for the result. Okay, we are getting same number of result 1229 number of prime numbers within the range of 1 to 10,000, and the time taken for this is 0.02 seconds. Okay, so this is the most optimized way of figuring out a prime number. So to conclude the session, with the naive approach where we were checking the divisibility of a number while iterating from 2 till n minus 1, we had the time of about 0.39 seconds for the range of 10,000. When we have cut down that to the second approach where we were just iterating from 2 till the half of the number, we had been able to reduce the time to 0.24 seconds for the range of 10,000. And when we have used the square root method, we were able to reduce that to 0.11 seconds. However, using the fourth approach, we were able to reduce the time to 0.02 seconds. Okay, so this is the most optimized way to figure out the number of prime numbers or get the prime numbers within a given range. With that note, we would like to conclude the session. If you have found this video useful, please share it with your peers and friends. Please give us your comments and feedbacks in the comment section below. And please subscribe to Naukri Learning for more such videos. Thank you.